In this video, I'm going to finish explaining the z-score of a sample mean. In the last video, I said that the z-score of a sample mean is a value that shows the number of standard errors that a sample mean falls below or above a population mean. And I showed you a diagram like this in the last video. So I showed you a diagram like this where we had a situation in which we had a population with a certain mean and a certain standard deviation, and a sample was being randomly selected, and a sample mean was being calculated. We calculated the standard error by dividing the population standard deviation by the square root of the sample size. And then we took the standard error and used it to plot the z-scores of 1, 2, 3, and also -1, -2, and -3. So here's just another example of a different situation. So in this situation, the standard error is 2. So once again, the population mean has a z-score of 0, and we're going up and down by 2 because that's the standard error. Now I want to show you the formula that's used to calculate the z-score of a sample mean. So we can use this formula to take any sample mean and turn it into a z-score. So in this situation right here, we could take 28.5 and turn it into a z-score using this formula, or we could take 24.2 and turn it into a z-score. So the formula for the z-score of a sample mean is the sample mean minus the population mean over the standard error. And this formula is very similar to the first z-score formula we learned, which was the z-score of an individual. That z-score was the data value, x, minus the population mean over the standard deviation. Now it's just the sample mean minus the population mean over the standard error. And this is the formula that you use to turn a sample mean into a z-score. Let's just do one example to practice this formula. So here we have a situation in which we have a population that has a mean age of 25 and a standard deviation of 4.9. A person randomly selects 18 people from this population, records their 18 ages, and calculates the mean age of the sample. The person adds and divides by 18, and the sample mean comes out to 24.5. So this is just an imaginary situation, and let's calculate the z-score of this sample mean of 24.5. Let's turn this number into a z-score. So we take 24.5, our sample mean x bar, we subtract it by the population mean of 25, and we divide by the standard error, which is the population standard deviation, over the square root of the sample size. These four numbers are all provided up here. The first step is getting the square root of 18, which is 4.24. Then we divide 4.9 by 4.24, and we get 1.16. Next, we subtract on top, and we get negative 0.5. And we divide, and we get negative 0.43. So this sample mean of 24.5 has a z-score of negative 0.43 in this situation. And the z-score is negative because the sample mean is below the population mean. 24.5 is below 25. So remember that when a number is below the mean or below average, it has a negative z-score.